Equilibrium constant. In the state of equilibrium for the reaction, A plus B will give C plus D. C plus D will also give A plus B. It has been shown experimentally that concentration of forward reaction over concentration of backward reaction is equals to a constant. That is, Kc is equals to concentration of C times concentration of D over concentration of A times concentration of B, where A in bracket and B bracket, it is referred to the molar concentration substance in equilibrium mixture. Ke is the equilibrium constant. Example 1. 2 mole of HL was injected into a box of 1 dm cube volume at 490 degrees centigrade. If 0.228 mole of that hydrogen iodide disappears, calculate the concentration equilibrium constant. Solution. Hydrogen iodide can also be a reversible reaction with hydrogen and iodine. Initial concentration 2 mole to give 0.0 mole of product. Equilibrium concentration is equals to 2 minus x, xx for the product. X mole of hydrogen iodide disappeared, and 2 minus 0.228 bracket 0.228 for hydrogen and 0.228 for iodine. Therefore, moles of hydrogen iodide reacted in equilibrium is equals to 1.544 mole per dm cube. At equilibrium, applying law of mass action, we have that Kc is equals to molar concentration of S times molar concentration of X over 2 minus S molar concentration raised to power 2, which we have 0.228 bracket 0.228 all over 2 minus 0.228, which will give us 0.016. Example 2. When 8.26 grams of ethanol were heated with 60 grams of ethanoic acid, 49.74 of that acid remain at equilibrium. Calculate the value of Kc. What mass of ethyl ethanoate should be present in equilibrium mixture formed from 13.8 grams of ethanol and 12 grams of ethanoic acid? Molar mass of ethanol is equal to 46. That of ethanoic acid is 60. 1 mole of ethanoic acid react with 1 mole of ethanol to give ethanoate, 1 mole of ethanoate and water. So initial concentration minus the concentration of the product all over V. Initial concentration B for the ethanoate, for the methane, minus the final volume minus the initial volume all over V. S over V for the ethanoate, and S over V for the water. Initial concentration of ethanoic acid is equals to 8.26 over 46 is equals to 0.18 moles. Initial mole of ethanoic acid is equals to 60 over 60, which gives us 1 mole. Final mole of ethanoic acid is equals to 49.74 over 60, which is giving us 0.829 mole. Number of moles of ethanoic acid which has reacted is equals to S is equals to 1 minus 0.829, which is giving us 0.171. Therefore, the equilibrium constant Kc can be calculated by applying the law of mass action expression. Kc equals to C molar concentration of ethanoate times molar concentration of water over molar concentration of ethanoic acid times molar concentration of ethanol, which is S squared over S A minus S times B minus S. Substituting the values in the equation gives Kc equal to 0.171 squared over 0.829 minus 0.171 bracket 0.18 minus 0.171, which you have 3.92. Number of moles of ethanol is equal to concentration over molar mass, which is equal to 13.8 gram over 46, which is giving us 0.3 moles. Number of moles of ethanoic acid is equal to 12 gram over 60 gram, which will give us 0.2 moles. From the above equation, the number of moles of ethyl ethanoate formed is equal to the number of mole X of acid or ethanol which disappeared. Using the value formed from the equilibrium constant in I, we have 3.92 is equal to S squared over 0.2 minus S times 0.3 minus S. That is 2.92 S squared minus 1.96 S plus 0.235, which is equal to 0. The value of S in the quadratic equation is A S squared plus B S plus C equals to 0. Using the almighty equation, S equals to minus B plus minus square root of B square minus 4A square all over 2A. By substituting the values, we have S equals to 0.514 or 0.158. The first of these values is inadmissible, since the number of mole of alcohol or acid which react cannot exceed the initial amount. Hence, S is equal to 0.158 moles. Therefore, mole of ethyl ethanoate formed is 0.158 mole. Therefore, the mass in gram of ethyl ethanoate formed is equal to molar mass times number of moles, which is equal to 0.158 times 88, giving us 13.9 grams. Chapter 16. Solubility and pH of solutions of some electrolytes. Electrolytes. Definition. Solute. A solute is any substance which is dissolved in a solvent. It may be solid, liquid, or gaseous. Solvent. A solvent is any substance in which a solute dissolves. Solution. A solution is a result in which a solute is dissolved in a solvent. It is homogeneous mixture of solute and solvent. An example is salt plus water equal to salt solution. The most common solvent is water, which dissolved in many organic salts, sugar, and alcohol. Saturated solution. A saturated solution at a particular temperature is one which can dissolve no more solute at that temperature in the presence of the catalyst of the solute. Solubility. This is expressed in terms of mole per dm cube, and it is defined as the number of moles of solute that form a saturated solution in 1 dm cube. By definition, solubility of salt is given by solubility equals to mass of